Infinite series. Echo. A series is formed by adding the terms of a sequence. I think you did this in like grade 10 or something, right? Series is formed by adding the terms of a sequence. An example of an infinite sequence is 0.3, 0.03, and so on. And the corresponding infinite series is, okay, replace the commas with plus signs. We can add the terms of a series together to create partial sums. For example, the sum of one term, right? S sub 1 is the sum of one term. S sub 2 is the sum of two terms, T1 plus T2, and so on. So, given this example, what's S1? 0.3. What's S2? 0.33. What's S3? And S4? In this case, it'll be like 4 3s. So, what is the limit as n approaches infinity of S sub n? So, we 0.3, 3, 3, 3, or 3 repeating, 3, 3, equals a dot. And we know that since the limit as n approaches infinity of S sub n is 0.3 repeating, which is 1/3, we say the sum of this series is 1/3. Okay, so the sum, remember, we're adding up an infinite series. Okay, sum of the infinite series is 1/3. If the infinite sequence, S1, S2, S3, of partial sums of the series T1 plus T2 plus T3, etc., plus Tn, has a limit L, that is, the limit as n approaches infinity of S sub n equals L, then we say the sum of the infinite series is L, and we write this in summation notation. Have you seen that notation? Yeah? Okay, good. Did it in 30 or something? 30-1? What does it mean? Just the sum of. So if I write down this, what is the sum of n equals 1 to 5 of t sub n? How does that expand? You've seen the notation. All right, let me ask again. Have you seen this notation before? Okay, have you been taught this notation? Do you know what it means?
It's the sum of one where we get.
It's yeah, no. All right. Apparently they left this out of your 30-1 education thing. Somebody left something out of the curriculum. What this means is you start with n equals 1 and you go to n equals 5 and you add up the terms, right? So it becomes, okay, well, put n equals 1. It's t1 plus t2. Then n increases by 1 plus t3 plus t4 plus t5. Okay? So it says it's the sum where n starts at 1 and goes to 5, going up by 1 each time, of t sub n. Okay, so in this case, t1 plus t2. It's just it's a way of writing, like instead of evaluating S4, right? So there's S3 is t1 plus t2 plus t3. And when we want to write it this way, where n equals 1 to infinity of t sub n, then we're saying that this simply is equal to L, but would expand to t1 plus t2 plus t3 plus ... Okay. Right, what do I have down here? Oh, and you can also do this, just to kind of show you. If we wrote the sum that n goes from 3 to 6, we would say start with 3 and go to 6, right? So it would be t3 plus t4. If anybody has any programming, you would set that as a loop, right? There'd be a parameter for the loop. You'd be increasing the thing, so increasing the loop counter. Anybody program? Computers? No? Both fast. Yeah, no. Okay. If you do go on and do any computer programming, this is a common construct, right? It's a loop. And then the sum of n equals 1 to infinity of t sub n would simply be t1 plus t2 plus t3 plus dot dot dot, right? Going on forever. So that's what this notation means, right? It's just a shorthand for a sum. Okay, or a partial sum, right? Here's the sum of 5 terms. I don't know why they left that out. We used to do that stuff. In this course, we're mainly concerned with geometric series. So geometric series has a what between successive terms, denoted by the letter R? Common ratio. So geometric series has a common ratio. And the general term of geometric series is given by t sub n is t1 times r to the n minus 1. Okay, nothing new there. And the sum of the first n terms of the geometric series is given by s sub n is t1 times r to the n minus 1 over r minus 1, where t1 is the first term. Excuse me, and I think there's an alternate formula, but that's one we're looking at here. For each geometric series, state the value of the common ratio, state the values of s sub 1, s sub 2, s sub 3, and s sub 4, and state whether each series is convergent or divergent. And if the series is convergent, then predict the value of the sum. So what will the value of the infinite series be? Okay, so 2 plus 4 plus 8 plus 16, what's R? R is 2, right? How do you get that? Well, just take any term divided by the preceding term, right? So you just kind of pretend there's commas there, 2, 4, 8, 16, 4 divided by 2. So R equals 2. What's S sub 1? 2. What's S sub 2? 6. What's S sub 3? I know you don't have a calculator, but still, really? Okay, 14. What's S sub 4? 30. Congratulations, your skills are getting better as we move along. Convergent or divergent? Divergent, right? What's happening? It's just getting bigger. There's some movie with that name. Like Limitless. Okay, 2 negative 4, 8 plus, sorry, 2 minus 4 plus 8. What's R?
Negative 2.
Negative 2. What's S sub 1? 2. What's S sub 2? Negative 2. What's S sub 3?
6.
What's S sub 4? Convergent or divergent? Well, if it's convergent, what's it going to converge to? No. I mean, eventually you're going to be adding numbers like 2048 and then subtracting 4192 and then so all you're really going to end up doing is exactly this, right? A small positive, small negative, larger positive, larger negative, larger positive, still yet larger from a point of view of size, negative, and so on. What's R? C, R equals 1. What's S sub 1? That surely has to be fairly easy. What's S2? What's S3? 4. Yeah, I'm not even waiting. Convergent or divergent? What's R for D? -1. What's S sub 1? 2. What's S sub 2? 2 minus 2. What's S sub 3? 2. What's S sub 4?
0.
Convergent or divergent? It's just going to be alternating, right? It's either 2 or it's 0. R. 1/2. 1/2. What's S sub 1? No. What's S sub 2? Now you can say 3/4. What's S sub 3? 7/8. What's S sub 4? Convergent or divergent? Convergent, and what is the sum? Convergent, convergent, and the sum to infinity will be 1. What's R?
-3/2.
Close, but
2/3.
yeah, that's it. -2/3, right? You just go -2/3 divided by 1. Or you look at it and say, hey, it's changing sign, and I'm always multiplying by 2/3. So. What's S sub 1? This would be the easiest of these ones. 1. What's S sub 2? This is the next easiest.
1/3.
What's S sub 3? 7/9, yes. And what's S sub 4?
4/27.
7/9 is what? 21 minus 8? Yeah, I can go with 13/27, I think. Oops. Convergent or divergent? Convergent. Let's leave what it converges on just for a moment. Okay. Some infinite geometric series are convergent, whilst others are divergent. For what values of R will an infinite geometric series be convergent? Between -1 and 1, yeah. So between -1 and 1, or we can say the absolute value of R is less than 1. Okay. All right. What is to be revealed? Ooh, if an infinite geometric series has a common ratio, where R is between -1 and 1, or the absolute value of R is less than 1, then the series is convergent, and the sum of the series is given by S is equal to T1 over 1 minus R. Another notation, the sum, as n goes from 1 to infinity, of T1 times R to the n minus 1, right, which is just, so this is going to be T1 times R to the 0 for the first term, right, then T1 times R, then T1 times R squared. It's just going to generate the sequence, is T1 over 1 minus R, which allows us to now flip back here and say, well, we can do this, right? So this sum is T1 over 1 minus R, which is equal to 1 over 1 minus -2/3, which is 1 over, so that's going to be 5/3, which is 3/5. So this series is convergent, and its value is 3/5. Okay. Determine whether each series below is convergent or divergent. If convergent, determine the sum. Okay, so what's R? r equals 1/2. Okay, so then we know it's between, that's between -1 and 1. So then we know that the sum to infinity is t1 over 1 minus r. t1 is 72 over 1 minus 1/2, which is 72 over 1/2, which is 72 times 2, which is
72 and 72.
which is
And 4 halves is 72.
4 times 36, 6 times 24, 12 times 12.
144 times y.
Yeah, it's 70. So if you like, then we just go to 72 times 2 times 1, right? It's 140. Okay, what's r?
Negative 2/25.
Yeah.
What there's a plus sign after the 4.
Yeah, it's okay. It's going to be plus negative.
Yeah, you're out afterwards.
You can add a negative. It's okay. So r, should we work that out, or are you okay with the negative? So it's negative 2/5 divided by 5, right? Which is negative 2/5 times 1/5, which is negative 2/25. So the sum to infinity is t1 over 1 minus r, which is 5 over 1 minus negative 2/25, which is 5 divided by 27/25. So what do we got? 125 over 27? Nice. Whoa. Right. And I heard somebody say that before I wrote that, right before I was writing it down. Hey, come on, you got it right. Okay, what's r? Negative 1/4, right? So this is written in the form, well, should we work out t1 first? Or whatever. Well, this is written in the form t1, okay, well there's t1, right? Because when n is 1, this is going to be 0, right? And you just have t sub 1, which is 3, right? So t1 equals 3, and then r is negative 1/4. So take a moment now, you can work it out, you've got a formula. So 3, 1. Get it? Get it? Huh? 12 over 5? Yeah. Small competition going on. It's good. It's written in a slightly different form. So what's T1? 5 over 8. And what's R? So you could generate a couple of terms of this, right, if you wanted to. So you just say, all right, so I'm going to put a 1 in there, so it's 5/8 plus. I'm going to put a 2 in there, so that's 25 over 64. And, 125 over 512. So T1 is 5/8, and R is also 5/8, right? Yeah. And sum to infinity is
Why is T1 5/8 rather than 1?
Okay, because you see at the bottom where it says n equals 1? So here it says you got to start this series out by putting n as 1. When I put a 1 in there, I get just 5/8. It's different. So here we say we start the series out. So an infinite series is always going to start with n equals 1 to infinity, right? Like the summation notation will always be n equals 1 to infinity. When it's written as the general term, so t1, or sorry, t sub n is t1 times r to the n minus 1. That's in this form. And basically you're taking the r out of the first term. Okay, so by doing the n minus 1. In this second case, it wasn't, right? It should be, or it could be 5/8 times 5/8 to the n minus 1. Okay, but you generally wouldn't do that because you could combine those two terms by multiplying and you'd end up with that. And ultimately, 5/3. Yep. We're going to learn one of these breathtakingly long calculus classes, which it's not going to be that long. Determine the value of x if each series below is convergent. Okay, so how do we do that? Well, what's r?
2x.
Yeah, so just, you take any term and divide it by the preceding term, right? So it's 2x. You don't have to show that work necessarily. You don't have to do two of them, right? But, I mean, it just verifies it. Okay, 3 times 2x is 6x, times 2x is 12x squared, times 2, yeah, okay, it's 2x. What do we know about r?
Must be in between -1 and 1.
Right, so we know -1 has to be less than r has to be less than 1, right? But what have we got? Well, we got r is equal to 2x. So we know that -1, or that 2x must be between -1 and 1. So what can we say about x?
Must one or x must be in between -1/2 and 1/2.
Yeah, so to get x by itself, what are we going to do? Divide everything by 2. Divide this by 2, divide this by 2, divide this by 2, and what do we get? -1/2 is less than x, which is less than 1/2. So that's the value of x, right? Any value between -1/2 and 1/2 will give you a convergent series. And I suppose it probably shouldn't be 0, or it's just sort of trivial, but, you know. And if you like that notation, then there's that notation. Okay, next one. What's r? 1 minus x, right? Or you can get that by inspection, right? And you just look at that and say, yeah, that's 1 minus x. You can get it by taking this and dividing it by 4. Or taking this and dividing it by this. But yeah, it's just 1 minus x. So what are we going to start off by saying? Well, we know that r has to be between -1 and 1. And we're going to replace the r with a 1 minus x. And we're going to do some magic here. So what are we going to do to this? We're going to isolate the x, right? So should we get rid of that 1 in the middle? So how do we get rid of the 1? We subtract it, right? So subtract 1 from everything. Gives us -2 is less than -x is less than 0. But we don't want a negative x. So what are we going to do? Multiply by -1. It's going to flip all the inequalities, right? And what are we going to end up with? Really, that x is between. X is going to be between 0 and 2, right? Yeah. Well, I mean, you could write 2 is less than x is less than 0, but really, I like going left to right. So x is between 0 and 2. Or x is between 0 and 2. So ready? Ooh. There are other infinite series that are not geometric, but are still convergent and are actually kind of neat to look at. So determine the value of the sum of n equals 1 to infinity of 1 over n minus 1 over n plus 1. Let's try writing a few terms out to see what we got, right? I mean, you know, how else are we gonna? So n equals 1 to infinity of 1 over n minus 1 over n plus 1 equals. So let's just start expanding it. So we start by making n 1. So what's 1 over 1? Just 1. Minus, what's 1 over 1 plus 1? So that's T1, right? The first term is 1 minus a half. Remember, this is not a geometric series. So we got to add T2. So what's T2? Well, that's going to be 1/2, because now n is 2, minus 1/3. Okay, what's T3? Well, that's going to be 1/3 minus 1/4. Okay, do you see a pattern going on here now? What's happening? Plus, would it help if I wrote these by, like I could rewrite this as 1 minus 1 over 1 plus 1, like do this as the second line? I don't know if I can move this down, apparently not. So maybe it would help you to see that it's 1 over 1 minus 1 over 1 plus 1. So there's T1, substitute a 1. 1 over 2 minus 1 over 2 plus 1. So there's T2. 1 over 3 minus 1 over 3 plus 1. Okay, and then write that as 1 minus a half plus a half minus a third plus a third minus a quarter. So what's happening if we remove the brackets? What's going to happen with these guys? What do these two add up to?
0.
What do these two add up to? What are these two, if I wrote the next one, going to add up to? What's the sum of the series? So all you're left with is 1. Right? So ultimately it looks like 1 minus a half plus a half, minus a third plus a third, minus a quarter plus a quarter, minus a fifth plus a fifth, minus a sixth plus a sixth. Ad infinitum. And that's just going to be 1. Okay. So the series is convergent, but it's not a geometric series, right? And you don't necessarily want to work out each term, right? I really don't want to do a half plus, what's a half minus a third? 3, 6, minus a half, plus a sixth.
12.
Yeah, well, it's gonna be a half, like minus a sixth plus a, I don't know, whatever, but yeah, it's just, don't do that, right? Because that's not gonna lead you to an answer. Okay, this, looking at the pattern, so expanding the series out, right? So if you don't have any idea about a series, just remember the summation notation, start with n equals 1, put a 1 in there, work it out, in a sense work it out. I mean, it's better to not work it out by saying, well, this is a half and then this is or whatever. It's better to work it out like this and then say, oh, hey, look, there's a pattern. Okay, is that it? That's it, right? Question? Comment? Concern?